Hey, my name's Casey, and if you want to see me walk through more LeetCode problems, you can subscribe. All right, so I'm going to do problem 1041, robot bound in a circle. So what do they give us? We have a robot that stands at 0, 0. So this is where he starts out, and he faces north. So he's starting at the origin. He's just facing up. Okay, in an XY plane. And they give us some instructions. So go, left, right. And they're going to give us this arbitrarily long string of instructions of go, left, right, whatever. So let's just look at this example here of like what it's doing. So they start at the origin, remember, 0, 0. And we're going to get two go instructions. So that means if we're facing up, we should just go up twice, right? So that's how we go from 0, 0 to 0, 1, 0, 2. They're just incrementing the y direction to go up. Okay, and then we do left, left. Now we're facing down because, left, left is down. Then we're going to get two go instructions. So we're just going to go down twice. So we're going to decrement the y twice. So 0, 1, 0, 0. Okay, and we're back at the origin. And they're saying that we would return true here. So what does it mean to return true? Return true if there exists a circle in the plane such that the robot never leaves the circle. So they have a very strange definition of circle here. All we did was we went up and then down, and they consider that a circle. I'm just gonna let's just change this word to oval because that's really what they mean here. And you could think, and by oval I mean, I know we just went up and down. You could just think of that as like a really skinny oval, right, with like no space in between the edges. So that's how I think of it. So anyway, the way I think you're supposed to go about this problem to see if basically if we're doing some sort of oval pattern, is you want to start with the simplest cases and incrementally play around with slightly more complicated cases. And as you start to it's kind of like induction almost, but as you can start to see as you build up these cases from the simplest case to the more complicated case, you'll be able to determine what cases lead to our little robot being in an oval or a circle, cycle, circuit, whatever you want to call it, and what cases lead to our robot being Buzz Lightyear and going to infinity and beyond and just not being bounded and shooting off to the moon. So let's actually start with the simplest case. If we're at the origin, right? Let's just say this is the origin. This is my robot. So let's say after we execute some amount of instructions, this could be 10 instructions, 0 instructions, 1,000, doesn't matter. Let's just say after all these instructions, I just end up right back at the origin. Then that means I am in a circle or oval or cycle, whatever. So we would return true here. So and it doesn't matter what direction we're facing, right? By the end of this. So let's say we ended up back at the origin, but we're facing right. Well, then if we were to repeat this, then we would just end up looking down, and we'd end up back at the origin again, and then looking to the left. It doesn't matter if we shoot off to Narnia and visit Hogwarts, do some zigzags over here. We're always going to end up back at the origin. So I think we can agree on that. So let's write that down. Let's see, after executing, or after single iteration of instructions, or single set of instructions, let's go with that. So if we execute these instructions one time, let's just say that we do. If after a single set of instructions we're at the origin, then we're in a circle, oval, cycle, circuit, whatever you want to call it. And so we would return true here. Okay, so that's one case, right? Or observation, and this might be a case, whatever. So we just have to keep going and kind of see what's happening. So let's say after all these instructions again, whatever, this could be 100 instructions, 5, 1 instruction, I don't know, it doesn't matter. Let's say that we end up with this, where, we could have gone off here, whatever, but the end displacement, we just went up once and we're looking up. Well, we can see pretty easily, if we were to repeat this, we would just end up going up again, right? So that's clearly unbounded. I'm definitely going to the moon on this one. So let's say let's just write that down. If we're not at the origin, so we know that it was okay to face up here. If we're at the origin, it didn't matter what direction we're facing at because we're going to end up back at the origin no matter what direction. But here, notice that if we're facing up, so and not at the origin, then we're not in a circle. So we're going to say false here. Okay, cool. And let's just say so now what you should do, or I think we should do, is we should test other directions. Let's say, well, what if after all those instructions that I implemented or that I executed, I end up facing down? Well, you could see, like, what did I do here? I went up and I turned around. I did 2 lefts or 2 rights, whatever, to face down. So I go up and then I turn around. Well, if I do that again, I'm just going to end up back at the origin and face this way, right? Okay, so if we're facing down, then, so basically if we're facing down, and we're not at the origin, we're okay. We're still in a circle. So actually, let's write that down. If we're facing down and not at the origin, then we're in a circle. And we're going to do this for the right. And we can just assume that if it's okay for whatever happens, whatever we determine from facing right, we'll determine is the same for the left side, because the left isn't special from the right. So let's just say we end up going up and to the right. Well, you could see if we did that again, if let's say we take a step forward and then we turn right again, and if we repeat this again, we're going to go take a step forward, turn to the right again, so we end up facing this direction, and we're just going to end up right back at the origin and then turning right. So we are in a circle. So as long as no matter what instructions, as long as we ended up with this up and this turning to the right, whatever, you can see that we end up in a circle. So let's write that down. If we're facing, and then because we're going to assume that right is the same as the left side. So if we did this, obviously if I did forward and I just turn this to the left, you would just get a square on this side. All right, so anyway, so if we're facing right or left, and not at the origin, oh my god, I can't spell, not at the origin, then we're in a circle. So we actually don't even need to say, actually, let's just leave this in here for now. So we can actually group this case, right? So if we're facing down, not at the origin, then we're in a circle. If we're facing right and left and not at the origin, then we're in a circle. So actually, if we're facing down, right, left, we are not at the origin, then we're in a circle. So I just combined those 2 cases. Okay. So now, and we're just going to, so maybe one of these will break, and we're just going to keep trying out stuff with these slightly, for example, so this time I went up, right? Now what happens if I say turn to the right and go this way? We're just going to try these little different scenarios to see how it affects these cases that we're writing up here. And you're just going to keep, and this is how I would approach the problem, just keep making these little observations and incrementally like fixing like what you've observed. So what do we do to end up here, right? So if we turn to the right, so because we start out like this, we'd have to turn to the right and then take a step forward to end up here. Okay, so let's just say after all these instructions, let's just say it boils down, because it essentially they would simplify to a right instruction and a go. So and this could be a bunch of goes, it doesn't matter. So let's see, so what would happen here? We would turn to the right, or what did I say? I've said turn to the right, then go. So then you would turn to the right again on the next iteration, and then you would go down, or you would just go, and then you would do it again. So you turn to the right, and then you'd go. I cannot do ASCII art. Okay, and then you turn to the right, and then go. And what do you know? Oh my gosh. Okay, and you can clearly see that this is a circle. And like, what did we write here? We said if we're facing down, right, left, and not at the origin, then we're in a circle. And notice that we are facing right by the end of this first iteration. This would be our first iteration of instructions. And we're not at the origin. So this case still holds true. Wow, that's awesome. Okay, so let's what if we were, oh shoot, my computer did something weird. Okay, so now let's say, so, and then we'll just, and if we were facing left, this would, you can see that this would just go forward, turn around, and then it would come back, right? This would actually come back in this direction back to the origin. So right and left is still holding true. If we were facing down, wait, did we do down yet? No, we didn't. Sorry. Okay. So if we're facing, let's say we took a step out here and we were facing down, then what happened here? So we started out facing this way. We would have to turn right. So turn right, then go, then turn right one more time. So if we did this again, we'd have to turn right. So we're going to turn this guy this way, go, and then turn right again. Now we're back at the origin. So we could see that this, if our final displacement, if after our final displacement, if we're facing down, then we're just going to end up back at the origin on the second iteration. So this still holds true. If we're facing down, left, right, and not at the origin, then we're in a circle. So now we're going to test, we should test if what happens when we're facing up. So if we're facing up, then what happens here? This boils down to a right, a go, and then a left. Well, if I just repeat this, I'm going to keep doing this. And you can see, oh, wow, like we're facing up and we're not at the origin. And we are not in a circle because we're just going to keep going out in this direction. Which means that this still holds true. If we're facing up and not at the origin, then we're not in a circle. Okay, I should have written true here. Okay, so we're going to do, we'll do one more. We'll just go for the down direction just to make sure, because maybe this is special, right? Like, what if we're facing down here, or what if we take we take a step in this direction, and then we're still facing down. Well, think about when, at first sight you think, well, wouldn't that just like do this? And it doesn't, because if you think about the instructions it takes to get to this, so it's right. Let's see, because we start out looking like this, so you'd have to do right to turn around, then you would do a go. Well, so you would turn right, go, and that's how you end up like this. Well, if we execute right again, what ends up happening is you have to turn around, and then you would just go in this direction. So this is actually, if we're facing down, and we're not at the origin, we are not, if we're facing down and we're not at the origin, we are still in a circle. So this is holding true. And we'll do this last one. So because remember, so let's just test the up direction. So what did it take to get here? We would have to turn around, so we'd have two rights in order to face this direction, in order to step in that direction. And then we're gonna have a go. So go to get here, but then how do we turn? We'd have to do two rights. So two rights, go, two rights. And if we were to repeat this, what ends up happening is you would turn right again, go, turn right, oh my god, I just had like a total brain freeze. You turn right, sorry, let's do that one more time. So we turn right, you turn right again, then you'd go. So now this guy is looking like this. And then you would turn right two more times. So you would look like this, then this. All right. So what do you know? If we're looking up, if we're looking up, because this was after the first iteration, and we're not at the origin, suddenly we're not in a circle. So I'm reading off this. And you can see that this is holding true. So now we've done the up direction, we did the right, we did the bottom. Now we're gonna do one last one, and because we want to make this a little more complicated, like slightly more complicated. And this is the last case. Well, what if we go on a diagonal? You know, let's just throw that in there. Let's say I do. So let's see. We're gonna start out like this. So this is considered the. I'm gonna consider this the origin. I'm just doing this to make it look nice. Let's say I go in this direction. Trying to get the spacing perfect so it's easy to see. So if I go off in a diagonal and I'm facing up, well, it's very easy to see that I'm just going to keep going in that direction, right? I'm just going to go forward and then up, forward and then up. Well, in this diagonal direction. Okay. So far the up thing of not being at the if we're facing up and not at the origin, then we're not a circle is holding true. Okay. Now, what if we're facing to the right? And I think this is the case that like throws people off because they don't understand why this is a circle or why. Okay, so, and this is what helped me visualize this. So we took 3 steps in this diagonal direction and we turned to the right 1 time. So look, notice from this guy's perspective, I just went to the right of like, yeah, I just went to the right. Well, if I do the same thing from this guy's perspective, now that he's here, so let's do this exact same steps. I'm actually just going to end up back at the x-axis. Okay, and if I repeat this again, so this would be facing in this direction now. And actually, let me put this on this line. Okay, so if I were to repeat this again, so now to from the robot's perspective, if I go diagonally to the right, it would be in this direction now, right? So let's type that out so you can visually see it. So I'm going to take a few steps in this direction. And this is just like the final, again, I'm making this really clear that this is the final displacement. Like, we don't care if what instructions led to this. Like, if we did a bunch of zigzags out here, like if this if the robot went out here and then out here and then went back over here, as long as we just care about the final destination. And so he goes in this direction, then he turns right again, which makes him turn this way. Actually, I'm gonna put that on another line so I keep the symmetry. Okay, and if he does it again, I think you can see what's happening. He's actually forming a circle or an oval, whatever you want to call it. Let's put. Oh my gosh. Okay, where's the backslash? ASCII art is difficult, guys. Okay, so he's gonna take 3 steps back to the origin. And okay, this 0 is in the way, but you can see, I'm just gonna delete the 0. You can see if this was our origin, right? Because this is where our robot starts. And my spacing is slightly off, but you could see how he's just doing a little circular shape if we turn right, because he's just gonna repeat this. And that's how you end up back at the origin 4 times. You just have this little diamond thing. And if we did it, say if we did it for the left direction, let's say we went left, right? You know what, I'm gonna, just so we don't mess this one up, we'll copy paste it. Bad idea, never mind, we'll start from here. So let's just pretend, let's get rid of all this. So I proved it for the right direction, that as long as we're not at the origin, that it's a circle. Okay, so this is our origin. We go up, and let's just say we were facing left. Well, what did I do? I went up towards my right, and then I turned left. So if I do the same thing, I'm going to go up towards my robot's right side. And now I'm facing, and then I'm going to turn left again, which means I'm facing down. And then we're going to do the same thing. We're going to go down my right side, which from the robot's perspective, this is his right. And you can see that the exact same thing is happening. I'm not even going to finish it because you can just see that this is clearly about to form a diamond if we just keep repeating it, and we're going to end up back at the origin. So facing right or left didn't change anything. So this means that if we're facing down, left or right, and we're not at the origin, then we're in a circle, and this is holding true. So now we'll do one last one. We'll do, this is the very last example, and I think that's we have literally gone over every case to isolate what our conditions are. So here's the very last example. If we just go up to our right, let's say in some diagonal direction, and we're facing down, then if we were to repeat this, we would go, from the robot's perspective, we would go towards our right and then turn around. And now we're just back at the origin after like 2 iterations, two loops of the instructions. So this just held true for all the cases I went through. And the only case that we saw where we were unbounded was this one case where we were facing up and we're not at the origin. So now we can actually, I think that's like, it gives you enough confidence that, and you could do this for like, if you weren't 1,000% sure, just do this for the other quadrants. But the other quadrants are not special. Like I don't see why like this quadrant would be different from any of the other quadrants. So that's my reasoning anyway. But yeah, so like, I feel like because now that I've gone through all the cases, I have enough confidence to say that like, yeah, these 2 cases will hold for like every case of these, and then now we can code it out. All we have to do is implement this. So if we're facing up and not at the origin, then we're not in a circle, and we're just return false for that and return true for everything else. So let's just keep going. So we want to code this out. So what do we want to say? Well, we need to know what direction my robot is facing, right? So let's just say 0 is up. So we're just going to say 0 equals up. And when let's say I get a right instruction. So if I get a right instruction, let's just say I'm going to increment the 0. Sorry, I'm going to increment the 0 to a 1. We're going to say 1 is right, or we could say, I guess, what do they use? They use north, south, east, west. So we'll say north. We'll change this. So this is east, and if I go right again, we're going to increment this again. So we're going to say what is this? Down, south, and then so I'm just going I'm going clockwise. So, and if I increment this again, if I get another right instruction, then I'm going to say we're facing west. Okay. So now we need to know, where is our current location? Yeah, we need to know what our current location is. How do I want to represent that? Let's just go with an X and a Y. So this is where our origin, right? This is where the robot's starting, X and Y. And we need to actually go through these instructions to see what direction we're facing and where we end up. So let's do that. So we'll just say char I for instruction in instructions.toChar array. And now we want to check what the instruction is. So if I is equal to right, so if we get a right, then our direction will equal direction plus 1, but we don't want to say we get like 10 rights in a row, right? We need to stay within the bounds of 0, 1, 2, 3. So we're going to mod it by 4. Yeah, okay. So this will give us, yeah, so we're just rotating at the right, and we'll do the same thing. We'll do the left really quick. So okay, so if we want to go to the left, actually we have to actually check because we could have a go instruction, right? So if we're going to the left, then I know we could, there is a mod trick to this. I'll show you 2 different ways that we could type this. So we could just do direction plus 3, and this just works. So it just like, it wraps around if you can kind of think about it. So like, let's say, let's just type it out really quick. So let's just say this was this was south, right? So this is equals 2. If I were to get Or no, let's just do west. Let's say we're at the end, right? If we're at west, s equals 3. All right, I just got that from here. Then if we want to turn left, well, if we turn left from, if we're facing west, we need to our goal is to get down, right? If we're turning left. Turn left would turn west into south, down, so, okay. So then adding this 3 would just wrap it, so this would be 3 plus 3 is 6, and then 6 mod 4 is 2, and 2 is south. Okay, I don't want to get too into this. This is just a cool little thing. You could like wrap your head around it and like digest it a little bit. That's up to you. I'm gonna write it my way, which is just super clear, which is just direction minus 1. But I'm gonna handle the case where if we hit 0, so if let's say direction equals 0, because we don't want -1, right? Then we're just gonna say 3 for the west. Okay. So this is just, I feel like this is more clear to me, but if you like the modulus way, that's fine too. Like either, whatever trick you want to do. So then, what do we do here? We got the direction. Oh, and then we have to handle the go instruction, right? So this is just a G, the go. So what do we want to do? Depending on the direction we're facing in, we need to increment our X and Y in those directions. So let's actually create some steps. So let's just say, let's see, let's do a pair of, or an array of pairs for the X and Y's. So steps equals new pair, and okay, we're gonna say, oh, and this has to be integers here. This is just gonna hold, you'll see what I'm doing here in a second. So if we're stepping, so let's say I'm facing north. If I'm facing north, I just want to go up. So I'm gonna increment my Y direction by 1. If I'm facing east, then I want to increment my X direction. And then if I'm facing south, I want to go down, so -Y. And if I'm facing west, then I just want to go in the negative X direction, whatever. Okay. So we have our steps that we want to take, or our go forward directions, whatever you want to say. And would do, let's see, take our current direction, and we want to say X plus equals, because these are pairs, we want to say get, well, this is just get key, which in this case is just X, and Y would be plus equals steps in this direction, get value. This is get value is just going to return the Y here. Okay. And I think that's it. So we can get rid of these parentheses to make this, clean this up a little bit. And all we need to do now is check these variables at the very end to see what direction we're facing, and just check our little what was our condition here. So if we're facing, so we want to return true if the robot is bounded. So let's just take one of these. So there was 2 cases where we returned true. If we're at the origin, so or we could just do return X equals 0. And we're going to say this, we're going to put in parentheses for one case. So we're doing this case here. If we're at the origin, or Y equals 0, then we return true here. Or the other case is if we're facing down, left, right, and we only get here if we're not at the origin, right? So this is if we're at the origin. Now the rest of this is if we're not at the origin. So if we're facing down, left, right, another way of saying that is we're just not facing up. So if direction is not equal to 0. So this is if we're not facing up. And that covers this and this. So now we should just, I think we're done. Let's just run it. What did I do? Oh, I left the X's and my ASCII art down here. Let's just take this out. I equals L. Oh, I forgot an equal sign. Cool. Let's submit it. Make sure it's right. Where did I mess up? Did I mess up a mod? No. Go. So what is if I'm at the origin, I'm good. If I'm not at the origin and my direction is not facing up, I'm good. So this is fine. Wait. No, this isn't fine. What's wrong with? Oh, I messed up my condition here. If we're at the origin, after all the instructions, we're definitely this part's right. What's wrong with this? So if we're not at the origin, oh, I'm so dumb. Sorry, guys. And so if X and Y are 0, that means we're at the origin, right? Because okay, I think that's a pretty silly mistake. Okay, so I just walked you through the intuition of how I would like step by step through this problem to like get my cases, and yeah, and then you just have to code out like those cases at the end, and that's pretty much the whole problem. So yeah, thanks for watching the video, guys, and if you want to see more, just subscribe. Cool, bye.